All right, in this lesson, we are going to be factoring trinomials. And so for a warm-up, we are going to multiply a binomial times a binomial. And so last semester, we did this using a box. I'm multiplying two terms by two terms. And so it kind of looks like a Punnett square, x plus 5 times x plus 2. X times x is x squared, x times the 2 is 2x, x times 5 is 5x, 5 times 2 is 10. And then from here, after we fill in the box, we're done multiplying. All we have to do is combine our like terms. And so 5x plus 2x is 7x. And so our final answer would be the x squared plus 7x plus 10. Okay, for this next example, we have 3x minus 4. You have to write your negative signs. You do not write plus signs, or you can if you want to, but you have to write the minus signs. And then 2x plus 8. 3 times 2 is 6. X times x is x squared. 3x times 8 is 24x. Negative 4 times 2x is negative 8x. Negative 4 times 8 is negative 32. My like terms are negative 8x plus 24x, which would give me 16x. And so my final answer is 6x squared plus 16x minus 32. Okay, and so now in this lesson, we are going to talk about how to do this in reverse. We are going to start with the x squared plus 7x plus 10, and our goal is to write the two factors that multiplied to give us that trinomial. This is a trinomial because there's three terms, and then these are binomials that are their factors. This is considered a quadratic because it has a square. These are considered linear because they don't have the square. So our goal is to factor each quadratic trinomial into two linear factors. Okay, and so how this works is we do something called factor by grouping. Okay, and so just to start, if we were to try to factor x squared plus 9x plus 20, you could kind of guess and check which two factors would give you that result. We know that we would have an x times an x for our first term in order to get x squared. And then to think about our last term, to get the 20, we could probably have like a 5 and a 4. Or we could have a 10 and a 2. And so how we pick these numbers is determined on what multiplies to give us 20, but what adds together to give us the 9. Okay, and so that's what we call the magic numbers. Is this is considered A, this is considered B, this is considered C. And so for this specific problem, A is equal to 1, B is equal to 9, and C is equal to 20. And so the magic numbers are two numbers that add to whatever A times C is, that 20, but multiply to B. Okay, and so A times C is 1 times 20, which of course is 20. And then we're trying to get two numbers that multiply to 20 but add to 9. And so something that's helpful is to make a t-chart of every numbers, all the pairs that multiply to 20, starting with 1. 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, and then we're back to 5. And so these are all the pairs. And so now you just need to pick one that adds to 9. And so 1 and 20, 2 and 10 don't work, 4 and 5. So these numbers are 4 and 5. Okay, and so for the specific case where A is 1, you can skip to writing your final answer at this point. You're going to have x plus 4 as one of your factors and x plus 5. Okay, and so I want to do every example that has A being 1, and we're just going to practice finding those magic numbers. So 1, 2, 3, and 4, and even 5. They all have A equal to 1, and so we're going to factor each of these by finding those magic numbers. I like to do what's called the X method just to organize my work. And so we're looking for two numbers that multiply to 14 but add to 9. Two numbers that multiply to 14 but add to 9. And so if I were to make a list of every number that multiplies to 14, 1 and 14, 2 and 7, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, and then we're back to 7. And so the pair that actually adds to 9 is 2 and 7. And so my magic numbers are 2 and 7. And so this factors to x plus 2, x plus 7. And you can multiply this back out using the box to see that it does multiply to x squared plus 9x plus 14. Okay, for this next example, we're looking for two numbers that multiply to 24 but add to 11. Multiply to 24 but add to 11. And so I make the t-chart for 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work, so these are all of them. And the pair that adds to 11 is 8 and 3. And so this factors to w plus 3 and w plus 8. And so just to show you, we can multiply this back out and test it. W plus 3 times w plus 8, w squared, 8w, 3w, 24. Add up our like terms, we get 11w in the middle. So w squared plus 11w plus 24. Okay, and so the factors are w plus 3 and w plus 8. X plus 2, x plus 7. Okay, here, be careful, we have a negative. So we're looking for two numbers that multiply to 35 but add to negative 12. Okay, make your t-chart for 35, starting with 1, 1 and 35. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7. 6 doesn't work, and then we're at 7. Okay, and so the pair that could get us to a 12 is 5 and 7, but we need them to add to negative 12. And so in order for that to work, they both need to be negative. Negative 5 plus negative 7 is negative 12, but if you multiply negative 5 and negative 7, they give you that positive 35. Okay, and so this would factor to p minus 5, p minus 7. Whenever your magic numbers are negative, you're going to see minus signs in those factors. Okay, here at number 4, we're looking for two numbers that multiply to negative 27. Don't lose your negative. And then add to 6. Okay, so don't worry about the negative yet. We're just going to focus on numbers that multiply to 27. Okay, so 1 and 27. Always start with 1. A lot of people lose that case. 2 doesn't work. 3 and 9. 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work. And so now, keeping in mind that one of these has to be negative in order to multiply to a negative, we're looking for a promising pair that could get us to 6. 1 and 27 cannot get us to 6, but 3 and 9 can if the 3 is negative, because 9 minus 3 is positive 6. If this were a negative 6, we would have made the 9 negative. So it has to be negative 3 and positive 9. So that means my factors are c minus 3 and c plus 9. It matters which one is positive or negative, because then it wouldn't add to 6 in the middle. Okay, last one like this. We are looking for two numbers that multiply to negative 28, not losing your negative, but add to negative 3. So making my t-chart for 28, we have 1 and 28, 2 and 14, 3 does not work, 4 and 7, 5 doesn't work, 6 doesn't work, and so that is all of our factors. And so now a promising pair to get us to 3, 1 and 28 definitely not, 2 and 14 definitely not, but 4 and 7 can work if we make the 7 negative. Because 4 minus 7 would get us that negative 3. But when we multiply them, they still give us that negative 28. Okay, and so R plus 4, R minus 7. Okay, so now in these next examples, 6, 7, 8, these each have a number in front of the squared term. And so we have some added steps whenever A isn't 1. So that's where we're going to go back to the beginning. And you still find the magic numbers by multiplying A times C. This time that number is going to be different than your C value because A won't be 1. And then what you do with those magic numbers is you split your middle term, kind of uncombining those like terms. So we have 4x and 5x, which would add back together to give us 9. And so once you split the middle term, and it can be in either order, you'll get the same answer at the end, you're going to factor 2 at a time, okay? And so I like to draw a line down the middle. And what you're going to do is you're going to look for a GCF out of each pair. So looking at my first pair, both of those can be divided by x. And then looking at my second pair, both of those can be divided by a 5. Okay, and so when we are factoring out this GCF, the GCF goes in front, so this x goes in front, and then what's left behind, just like when we were factoring the GCF, goes in the parentheses. X squared divided by x is just x. 4x divided by x is just 4. For the second pair, 5x divided by 5 is just x. 20 divided by 5 is 4. What's great about this method is if you're doing everything right, you have the right magic numbers, you have the right GCFs. If you have done everything correctly, this expression in the parentheses on each side should match. That x plus 4 is going to be one of your factors, and whatever is outside the parentheses is going to group together to become your second factor. The x plus 4 is what's in common, and so we pull it out to the front, and then what's left behind gets written in these parentheses. Okay, so it seems like a lot of steps, but once you get the hang of it, it goes really fast. So let's do number 6. Okay. So this time we are looking for two numbers that multiply to 3 times 4. 3 times 4 is 12, but still add to 8. Okay, and so if you want to make your tree, those numbers end up being 2 and 6. Okay, and so 2 and 6, you take your middle term and split it. So 2k plus 6k. Make sure when you combine those back, it gets you the 8k. Copy down that last term, copy down the first term. Okay, and so you're splitting the middle so that you can divide it right down the middle and factor 2 at a time. So out of the first pair, they both have a k in common. You'll always get the variable out of the first pair because that's your x squared term and your x term. You may or may not get a number. Okay, and so k is the GCF, and then what's left behind, 3k squared divided by k is just 3k, 2k divided by k is just 2. For the second pair, between 6 and 4, both of those can be divided by 2, and you're never going to get a k because this is where your constant is. And so 2 is the best we can do. 6k divided by 2 is 3k. 4 divided by 2 is 2. So notice our parentheses match. That means we've done everything right. 3k plus 2 is one of my factors. And the other factor comes from the k plus 2. It's positive. Make sure you write it in that order. And so this would be our final answer. I'll get rid of this highlight. Okay, and again, you can still multiply it back out to check your work. So 3k plus 2 times k plus 2 gives me 3k squared, 6k, 2k, and then 4. And then when we combine our like terms, we get 8k. And so 3k squared plus 8k plus 4, which was our original polynomial. Okay, next example. We are looking for two numbers that multiply to 7 times negative 6, which is negative 42, but add to negative 19. Okay, these numbers are kind of large, so it might be helpful to make your t-chart or your factor tree. So 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work, 6 and 7, and then we're back to 7. Okay, and so looking for a pair that can get us to 19, 1 and 42 doesn't work, 3 and 14 doesn't work, 6 and 7 doesn't work, but 2 and 21 will work if we make the 21 negative. That way they add to negative 19, but multiply to negative 42. Okay, now notice you can't just jump to writing n plus 2, n minus 21 here, because if I were to multiply all this back out using the box, I would get n squared, not 7n squared. And my last term would be negative 42, not negative 6. And so just be careful. Don't jump to the factors unless a is 1. Here a is 7. Okay, so what you do with those magic numbers is you split the middle. And so instead of negative 19n, I have 2n minus 21n. Bring down your minus 6. Bring down your 7n squared. Okay, and so divide it right down the middle, and then you look for a GCF out of each pair. Okay, so looking at the first pair, they both have an n. So when we divide by n, that leaves us with 7n plus 2. And then out of the second pair, we talked about this in the GCF lesson. If your first term is negative, your GCF is automatically negative. You don't care what this sign is. If the leader is negative, your GCF is negative. And then between 6 and 21, 3 would divide both of those. Okay, and so that leaves us with positive 7n once we do that division, and then positive 2. Once again, our parentheses match. That means we are doing everything right. So 7n plus 2 is one of my factors. And then n minus 3, in that order, is my other factor. Again, it doesn't matter which order you put these numbers in. You'll get the same answer in the end. If you were to switch those around, 7n plus 2 would have been your outside factor, and the n minus 3 would have been your inside factor. Okay, here we are looking for two numbers that multiply to a times c, which is 40, but add to negative 22. Okay, 20 and 2 multiply to 40, but to add to negative, they both need to be negative. That way they still multiply to positive, but add to that negative 22. Okay, so splitting our middle, either order, negative 20t minus 2t. Make sure you do your t's kind of with a loop so they don't look like plus signs. Plus 5, 8t squared. Okay, factoring 2 at a time. out of the first pair, between 8 and 20, 4 divides both of those, and then they both have a t as well. So 4t would be the GCF. After the division, 8 divided by 4 is 2, t squared divided by t is t. Negative 20 divided by 4 is 5, and then the t cancels. Out of the second pair, my leader is negative. And then there's nothing else in common, and so 1 is the best we can do there. There's always at least a 1. So negative 1 is what we are dividing by in this case. Negative 2 divided by negative 1 is positive 2 with the t. 5 divided by negative 1 is negative 5. Once again, the parentheses match. 2t minus 5, that's just one of your factors. The other comes from the 4t minus 1 in that order. Okay, for this next example, a is 1 again. And so we are looking for two numbers that multiply to 40, but add to 5. And then as you're making your list of numbers that multiply to 40, we have 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, 6 doesn't work, 7 doesn't work. So these are all the possibilities. And so we're looking for a combination of these numbers that would add to 5. 1 and 40 doesn't work, 2 and 20 doesn't work, 4 and 10 doesn't work, 5 and 8 doesn't work. So when there are no magic numbers, this is considered not factorable. Another name for not factorable is prime. Okay, not factorable or prime. Okay. This next one has a note. It says you may need to factor out a GCF before factor by grouping. Okay, and so before you start, if A isn't 1, see if there is something you can divide every term by. In this case, the leader is negative, so I'm automatically going to include a negative. At very best, we would be dividing all of them by -1. But in this case, 3 actually divides each of these numbers. Okay, and so -3 would go outside the parentheses, and then we're going to have a trinomial left behind. -3 divided by 3 is 1 with the b squared, and you don't have to write the 1. -9 divided by -3 is positive 3b. 12 divided by -3 is -4. Remember, everybody's sign is going to change when you divide by a negative. Okay, and so now we are working with a simpler quadratic where a is 1 again. And so we just need two numbers that multiply to -4 but add to 3. Two numbers that multiply to -4 but add to 3. And so this is the case where a lot of students can't find the numbers because it's 1 and 4. But the negative has to go on the 1 in order to add to 3. And so because a is 1, we don't have to do the grouping. We can go straight to writing our factors, b minus 1 and b plus 4. Order doesn't matter. But do not forget to write that -3 from the very beginning. Otherwise, you're missing your factor. If you were to multiply it all back out, it wouldn't get you the original expression. Okay, let's skip to number 12. A rectangle has an area of 3x squared plus 6x plus 3. So we're picturing a rectangle, and his area, his length times his width, is this trinomial expression. What are the dimensions of the rectangle? So we're trying to find expressions to represent the length and the width. So we're trying to figure out what multiplied together to give us the 3x squared plus 6x plus 3. And so this is an application problem for factoring. And so just like that previous example, each of these numbers can be divided by 3 right off the bat. which would leave us with x squared plus 2x plus 1. So now we're looking for two numbers that multiply to 1, but add to 2. Again, a is 1, so that makes this a lot easier. We just need these magic numbers. Okay, and so two numbers that multiply to 1 but add to 2 are only 1 and 1. And so this case, our factors are x plus 1, they match. And so the dimensions of the rectangle, we do have that GCF of 3. And so because we're not talking about a square, and we have this extra factor here, you can distribute that to either one of the parentheses. And so if you wanted to make the width be the 3x plus 3, and the length be the regular x plus 1, or vice versa, one of them will have that factor of 3 distributed to it, but not both. Okay, and so the dimensions of the rectangle are 3x plus 3 and x plus 1. If you were to multiply that all back out using your box method, we would get the original expression back. So 3x times x is 3x squared, 3x times 1, 3 times x, 3 times 1. And so that would give me 3x squared. Combine your like terms to get 6x. And then plus the 3 at the end. And so that was our original expression. And so your answer is 3x plus 3 and x plus 1 are the dimensions.